both sides of the equation by the quantity that is equal to the coefficient of the variable. So we have to divide both sides of the equation by 16. So after dividing, we have the result is k squared is equal to 9, and to solve for the value of k, we have to square or take the square root of both sides of the equation, or using the square root property to solve for the value of k. So after taking the square root of both sides, we have k is equal to positive and negative 3. Now, so how do we know if we have the right or the correct answer for the problem? So let us now check for the roots of the quadratic equation. So if k is equal to negative 3, then we have 9x squared minus 4 times 3x plus 4 is equal to 0. Then we have the quadratic equation as 9x squared minus 12x plus 4 is equal to 0. So solving the quadratic equation by factoring method, we have 3x minus 2 and 3x minus 2. Why? Because 9x squared minus 12x plus 4 is a perfect square trinomial. So to check whether the given quadratic equation is a perfect square trinomial, so we have to get the square root of the coefficients of, or the terms of the first and the last term. So we have 9x squared, the square root of 9x squared is 3x, and the last term is 4, and the square root of 4 is 2. So if we will multiply the product of the first, or the square root of the first and the last terms, that should be that should agree with the middle term of the perfect square trinomial. So we have 3x times 2 is 6, double or multiplied by 2, we have 12x. So that means 9x squared minus 12x plus 4 is a perfect square trinomial. So to factor, we will just take the square root of 9x squared, that is 3x, and the square root of 4 is 2. So since the middle term is negative, so the factor of 9x squared minus 12x plus 4 is 3x minus 2 quantity square, or simply 3x minus 2 times 3x minus 2. So using the zero product property, we can have 3x minus 2 is equal to 0, and the other one is 3x minus 2 is equal to 0. Then solving for x, we have x is equal to 2 over 3 for x sub 1 and x sub 2. Okay, now if x is equal to negative 3, then we have 9x squared minus 4 times negative 3 x plus 4 is equal to 0. Then we have 9x squared plus 12x plus 4 is equal to 0. Again, 9x squared plus 12x plus 4 is equal to 0, and that is a perfect square trinomial. So the factor of the perfect square trinomial is 3x plus 2 quantity square, or 3x plus 2 times 3x plus 2 is equal to 0. Then solving for x, we have x is equal to negative 2 over 3, and the other one is x is equal to negative 2 over 3. Okay? So let us have example number 6. So for what value of C, thus 2x squared minus 6x minus C is equal to 0, have imaginary or non-real complex roots. So, for the roots of the quadratic equation to be imaginary or non-real complex roots, the discriminant or b squared minus 4ac must be less than 0. Okay? So, we have 2x squared minus 6x minus c is equal to 0. So, we have to identify again the value of a, b, and c. We have a is equal to 2, b is equal to negative 6, and c is equal to negative c. Okay? So, since the condition will be b squared minus 4ac is less than 0, so we have to substitute the values of a, b, and c. Then we have negative 6 squared minus 4 times 2 times negative c is less than 0. Okay, so solving for c, we have 36 plus 8c is less than 0. Then 8c is less than negative 36. Then c must be less than negative 9 over 2. And negative 9 over 2 is also the same as negative 4.5. Okay? So, therefore, the value of c are the numbers that is below negative 9 over 2 or simply negative 4.5. Okay, so let us now check. If c is less than negative 9 over 2, where c can be negative 5, negative 6, negative 7, and so on. So we will just choose c is equal to negative 5. So for c is equal to negative 5, we have 2x squared minus 6x plus 5 is equal to 0. Okay? So the value of a is 2, b is negative 6, c is equal to 5. So substituting the value of a, b, and c in b squared minus 4ac, we have negative 6 squared minus 4 times 2 times 5. So that is equal to 36 minus 40, and 36 minus 40 is negative 4. So since negative 4 is less than 0, then the roots of the quadratic equation 2x squared minus 6x plus 5 is equal to 0 are imaginary or non-real. Okay? To summarize what we have discussed for this week, the roots or solution of a quadratic equation can be real or imaginary, rational or irrational, equal or unequal. Okay? So we can determine the kind or simply the nature of root of a quadratic equation by the value of the discriminant, which is also equal to b squared minus 4ac. It is also the expression inside the square root of the quadratic formula. Determine the discriminant. Determining the discriminant is important so that we have an idea of what kind of solution that a given quadratic equation has. So let us now have the nature of roots of a quadratic equation. Again, if the discriminant b squared minus 4ac is equal to 0, so the nature of roots or the roots is real, rational, and equal. Now, if the discriminant is greater than 0 but a perfect square, we have real, rational, and unequal. If the discriminant b squared minus 4ac is greater than 0 but not a perfect square, we have real, irrational, and unequal. And if the discriminant is less than 0, then that is an imaginary root. Okay, so after the discussion, you have to try some of these problems for the discriminant of a quadratic equation. So letter A, you have to determine the value of the discriminant, the nature of roots of the following quadratic equations. For letter B, you have to find the value of k that will make the roots of 3x squared minus kx plus 12 is equal to 0, that is equal. And number 2, you have to find the value of k that will make 16x squared minus 4kx plus 25 is equal to 0 on imaginary roots. Okay, so that's all guys, and hope to see you next week. Again, this is Sir Raymond Cruz for the lesson of nature of roots of a quadratic equation. Thank you and goodbye.